Now let's form a dilation that actually goes in two directions at once. So you'll recall that the basic form of a circle is x squared plus y squared equals r squared. Now that's a circle that has its centre at the origin. So we can go ahead and draw that very easily. If the circle had its centre somewhere else, of course, we already know this formula too, where the centre would be hk. But in this case, if we've just got x and y, we'll just keep it really nice and simple. We don't want to make dilations and translations at the same time. I mean, we can, but not today. Let's just do the dilations first. Okay, so we're going to take this circle and we're going to stretch it horizontally by a factor of 4 and vertically by a factor of 2. So let's think what we need to do to our formula here. Now, stretching horizontally, just think it through. If you're stretching horizontally, you're going like this. So you're changing the x values the most, aren't you? You're actually ripping it away from the y-axis, which is your axis of dilation, but you're changing the x's. So if we want a factor of 4, we'll need to replace the x with x over 4. And of course, it still needs to be squared. Now, if we're stretching vertically, that means we're changing the y values. We'll need to replace y with y over 2. So it's quite simple to make these substitutions. And there you have the formula for your new stretched circle. Now, a stretched circle that's stretched more one way than the other is going to actually make an ellipse. So let's think about how we're going to stretch it. It would be quite easy to find the x and y intercepts here by just letting x equal 0, letting y equal 0. We can see that if we've stretched horizontally by a factor of 4, everything's going to be 4 times as far away from the y-axis. So instead of this intercept here at -1, it will be out here at -4 and 4. And if we stretch vertically by a factor of 2, instead of going through 1, it will go through 2 and -2. So we'll end up with an ellipse that looks something like this. Now you can check that with your algebra by subbing in let x equal 0. We would have 0 here, and so y over 2 all squared would be 1. And so y over 2 would equal the square root of 1, and so plus or minus the square root, sorry. So y would equal plus or minus 2, and sure enough, that's what we found just by using logic to think it through. And you'll find the same thing if you let y equal 0 to find your x-intercepts. So what that gives us then is a really nice formula for an ellipse. Now you'll notice here that instead of using a for both the stretching factors, we've used a and b just as a way of telling them apart. And we've still got 1 here because virtually every ellipse you could think of it as starting with a radius of 1 and then being stretched to the size that it needs to be. So we don't really need to have r squared in there. We can literally just keep it as 1 because the amount that it's stretched will tell you how wide and how tall it is.